Data from two independent random samples are shown in the table below. Both populations are normally distributed. The means for the two populations are thought to be the same. Does this sample data provide evidence of a difference in the population means? Test at the 5% significance level. Okay, so first we're going to establish the claim. We are testing and asking the question, does the sample data provide evidence of a difference in the two population means? So what we would be saying then is that mu A does not equal mu B. And from there we can form mu A minus mu B should not be equal to 0. So this is our claim. This claim does not contain equality, therefore it becomes the null hypothesis, or the alternative hypothesis, and the null hypothesis will take the alternative view that mu A minus mu B does in fact equal 0. Now let's state the level of significance for the test and circle which type it is. So alpha, we are told we wanted to test at the 5% significance level. This will be a two-tailed test. It comes from the null hypothesis, and we have inequality. And now we can determine the type of sampling distribution. This the standard deviation is unknown. We have independent random samples, and the population is normally distributed. So this will tell us then that we'll be using the two-sample t-test. And then we can draw the diagram and determine the critical value of the rejection region. So since we're using the t-test, we need to take we need to determine the degrees of freedom, and we'll use the smaller of n-1 or n-2. So we are looking at either 25 minus 1, which is 24, or 16 minus 1, which is 15. The smaller of those two is 15, so we will use 15 degrees of freedom. We'll be looking for a two-tailed test, so we need two critical values. They'll be the boundary of the rejection region. We're at the 5% significance level, so we will split that and have half in each tail. And then we can look up on the table and we'll see that the critical value here is 2.13, and then by symmetry this one must also be negative 2.13. Now from there we can determine what the test statistic is. Now if this test statistics falls in the rejection region, we'll reject H sub 0, and if it's outside of that, we will not reject H sub 0. Okay, so let's fill this in. So we have to find x1, which is x bar 1, which is given as 5, and then x bar 2 is given as 4.7. Close that, and then we'll subtract off the difference between mu1 and mu2, or A and B, and we've assumed that to be equal to 0. After that, in the denominator, we'll look for the first sample standard deviation, which is 1, square that, and divide by n1, which is 25, plus for the second sample, the standard deviation is 1.2, that needs to be squared, and then divided by n2, which is 16. And then we can start simplifying. So for the numerator, we will get 0.3, and in the denominator, you should come up with 0.3605. And when you divide those two, we get 0.8322, and this is our test statistic. And we can label that on the diagram. So if we come up here, 0.8322 is outside of the rejection region, so we will not be rejecting H sub 0. But remember, we also have the negative value over here, and we'll need that to determine the probability in the red, and we will show that that is larger than alpha. So in step 7, we're asked to find the p-value of the test, and the p-value will be, we need both tails, so you can either take 2 times the probability that t is less than the negative value, which is negative 0.8322, or you can take 2 times the probability that t is greater than the right-hand value, which is positive 8322. Either way you do it, when you come up, what you should come up with is 2 times 0.2092. So the associated p-value is 0.4184. Therefore, we will not be rejecting h sub 0 for a couple different reasons. Either the p-value method, that 0.4184 is greater than alpha, which is 0.05, or because our test statistic, which is 0.8322, is greater, or I'm sorry, is less than the critical value, which is 2.13, meaning it is outside of the rejection. And with that, then we can make the formal conclusion for the test. We can say at the 5% significance level, there is not sufficient evidence to support the claim that there is a difference in the two population means. Now we can also construct the confidence interval for this test. To do that, we'll use our calculators. I've just summarized the values for A and B. We'll go to stats, test, and then the 2 sample t interval. We'll want to be inputting stats. The confidence level will be 1 minus alpha, so 0.95. And again, do not pool the data. And when you do this, you should come up with the interval. It says negative 0.4387 will be less than mu1 minus mu2, or mu A minus mu B, which will be less than 1.0387. So what does the confidence interval suggest about the claim that there is a significant difference between the two population means? Well, the null hypothesis assumes that mu1 or mu A minus mu2 or mu B is equal to 0. And since 0 is included in this interval, negative 0.4387 up to 1.0387, since 0 is included in there, we can say that there is not sufficient evidence to support the claim that there is a significant difference between the two population means.